Okay, perimeter. So here we have what we call a composite shape. It's a shape made up of two shapes. So we've got a semicircle along the top, and then we've got two sides of a triangle at the bottom. So if I was going to do the perimeter of this, obviously the triangular part would be easy. I've got 4 plus another 4 because these markers tell me that these sides are the same. And then the hard bit is I need to get the little arc across the top of here, of this, or the semicircle. So to get that arc or semicircle, I'll write that down. But basically we're going to use the formula for the circumference of a full circle, which is 2 times pi times my radius. And in this case that's 2 times pi times 2. Because what we know here is that they've told us, and I'll just change colours, they've told us that all these sides are the same, which means that this full bit here would be 4, and the radius of course is just going to be a half of that, so therefore I'm going to have a radius of 2. That would give me the full circle, but I've only got the half of a circle, so I can just divide that answer by 2, and that would give me a semicircle of 6.28 centimetres, the arc sort of length of that. And then plus I have to add on the 2 4s for the straight lines there. So I've got the 2 parts of the triangle. So altogether I've got that 6.28 plus one of the radius plus the other radius, which will give me a total answer of 14.28 centimetres. And because I'm in centimetres, well, those decimal places actually mean millimetres, and so it would probably make sense for me to round this to 1 decimal place, which would be a millimetre. In order to round, if I'm going to stop at 1 decimal, I check the next decimal, which in this case is an 8. If my next number is a 5 or more, then I round up. So in this case, I would round this to 14.3 centimetres. Okay, and now we'll go on to area. So area is the amount of surface within a perimeter. So it's measured in square units. So for example, it might be measured in centimetres squared or metres squared, millimetres squared, kilometres squared, which would be very, very big, or whatever. Now, one of the first things we need to learn to do is to convert units of measurements. I've started this little thing here because we've used hectares for the first time. Hectares, of course, are an agricultural measure of land, and so we need to be familiar with that here. 1 hectare is equal to 10,000 square metres, and I might just write that one up the top. So 1 hectare is equal to 10,000 metres squared, and that's all inherently a square unit. And so what you'll notice here is that there's no power on the hectares. We don't need there to be a power there because it's already implicitly a squared measurement. So to go from kilometres to hectares, we're timesing by 100. To go from hectares to metres squared, we're going to times by that 10,000 because we know that there's 10,000 metres in each hectare. Now, for the other conversions, rather than give you just a number to multiply by, what I want you to do is to think about the process. Most people, if I said to you, if I said to you to convert from metres to centimetres, what most people want to do is to tell me to times by 100, because we've all got that 100 centimetres in a metre sort of concept burned into the back of our brains. But when we're talking about squared measurements, we need to multiply by whatever our usual scale factor is, but we need to square it. So in this case, it's 100 squared, which is actually 10,000. So if I said 100 squared means 100 times 100. Mentally, 1 times 1 is 1, and I've ignored 4 zeros there, so I need to put 4 zeros back on. So my scale factor there is 10,000. But rather than try and remember that, what I want you to remember is that it's just your 100 as usual. But just remember, if I'm looking for squared units, then I need to square that factor. By the same sort of process, if I was going from centimetres to millimetres, we all remember that normally we'd be timesing by 10 to convert from centimetres to millimetres. But if it's squared units that I'm using, then I need to use 10 squared, which is 10 times 10, which is of course 100. But rather than remember that, just remember that to square whatever you'd normally do. Same going in reverse, I'd be getting smaller, so I'd be dividing by 10 squared here. Or if I go from centimetres to metres, I would be dividing by 100 squared. Now, I'm just going to explain this further, because in maths, rather than memorising things, if you understand it, you won't have to memorise it and you'll get in less strife. So I'm just going to illustrate this concept that I was talking about. If I said to you that this was a cube and I said that it was 1 metre by 1 metre by 1 metre in dimensions, then you would happily tell me, if I said to you, well, actually in this case we're just doing squared areas and not volumes. So what I'll do here is just look at the face of this shape here. Now, in this case, if I asked you what was the shape of this face, you'd say, well, 1 metre times 1 metre is 1 metre squared. If I then asked you to convert it to centimetres, the bulk of my students will always just times that by 100 and try and tell me it's 100 centimetres squared, which is not going to be correct. And the thinking, if I showed you, you will understand. If I asked you to convert it to centimetres first, you'd now say that each side was 100 centimetres. So that one there is also 100 centimetres. And then if I said, what's the area, you'd be going 100 times 100, which is of course 100 squared, which would give you the 10,000 centimetres squared, or 100 squared. And so you can see, hopefully, how that logic works and why that works. It'll be the same when we get to volume, except of course we're going to do it to powers of 3. So let's convert these things. So the first one, let's convert metres squared to hectares. So if I'm going from metres to hectares, you can see that I'm going to be getting smaller, and I'm going to be dividing by 10,000. Now 10,000 has 4 zeros, 1, 2, 3, 4, so I'm moving my decimal effectively 4 places. Where there's no decimal, you're at the end, and I'm going 1, 2, 3, 4. So I'm going to wind up there with an answer of 3.84, and I don't need the extra zeros, hectares. And again, I don't need to put a squared unit on there because it's implicitly a squared concept. Now if we did the next one, B, 25.7 hectares to metres. So if I'm going from hectares to metres, I'll change colours here. You can see hectares to metres. I'm going to be timesing by 10,000. I'm going to be getting bigger. So timesing by 10,000, and I'll write it above so you can see my process. So 25.7 timesing that by 10,000. I've got 4 zeros, so I'm moving that decimal 4 places. I'll just show you that in case you have to do it mentally. So 1, 2, 3, 4 would put my zero there, my decimal there, and I've lost it from there. I'd fill up my spaces with zeros, and so all up I'd have 257,000, which is 257,000 metres squared. Doing D, I'm going from centimetres to metres. So here, I know that I'm going to get smaller. There's lots of centimetres per metre, so I'm going to get smaller, and I'm going to divide that by 100 squared. So again, if I had to do that in full, so I've got my 500,000 divided by 100 squared, which is 100 times 100, which means I'm going to have 4 zeros. So I'm moving this decimal 4 places, 1, 2, 3, 4, if you do have to do it mentally. So that's going to give me an answer of 50 metres squared. And this is very important because we'll often have to do these conversions. Looking at your next one, 18 centimetres squared to millimetres squared. We know that ordinarily if I go from centimetres to millimetres, I'm going to get bigger. Therefore, I'm going to be multiplying. Normally I'd multiply by 10 to go from centimetres to millimetres, but because they're squared units, it needs to be 10 squared, which is of course 100. 10 times 10 is 100. So I'm going to be moving this decimal 2 spots, which will give me 1,800. And so on. I'll let you do the last couple on your own. Now, that will bring us to some shapes. Actually, I might start these in a separate video because they get too big.